Good afternoon, everyone, and welcome to this lecture. This is lecture number 13, and we are dealing with pseudo force. In this particular class, we will try to wind up this pseudo force, doing some good examples. In the previous case, you had seen how we solve problems on pseudo force. The problems were pretty simple. What we had to do is that to take in account pseudo force, we just have to apply a force MA in the opposite direction to the direction of acceleration. Do we remember this? Yes or no? Apart from that, the question remains exactly same. The only thing that happens is once we are applying pseudo force and making the equation from the accelerated frame, we will always get the answer from the accelerated frame of reference, not from ground. Do we understand this? Yes or no? Anyone has any doubts on this? Well, then we can bounce out and move on to the next topic. And the next topic is a very small one, but we can have some questions on this. The next topic is the topic of weighing machine. The next topic is the topic of weighing machine and spring balance. I'm just clubbing them together because they are of the same concept. What do you mean by a weighing machine and what do you mean by a spring balance? Most of you would have used a spring weighing machine. Some of you might have used a spring balance as well. Now, the question is, what does a weighing machine do? Yes. What does a weighing machine do? Anyone? What does a weighing machine do? What does a weighing machine measure? Tell me. What does a weighing machine do or what does a weighing machine measure? Anyone? Anyone can answer? What does a weighing machine do? What does a weighing machine measure? Yes.
Measures the weights.
It measures the weight. So if you are standing on this weighing machine, it will tell you your weight. Yes or no? Now that is a wrong concept. It does not measure your weight actually. Now if I draw the free body diagram of this gentleman, the weight of this gentleman is acting downwards and the normal reaction, which is the weight, normal reaction, which is the force applied by this man on the weighing machine is going upwards. Now, if I look at the if I look at the equilibrium of this person, I can see that this normal reaction will be equal. Let me write it here. That this normal reaction would be equal to the weight of this gentleman. Do we understand this? Now, the question was, what does a weighing machine measure? What does a weighing machine measure? It does not measure the weight of the body or the weight of the person standing on it. It only measures what? It only measures the value of this N. This is N, the normal reaction that the machine measures. It never measures your weight. It only measures the normal reaction or the force exerted by object on its upper surface. Do we understand this? A weighing machine does not measure the weight of a body. It only measures what? It only measures the force applied by the body onto it. Do we understand this? So remember this, a weighing machine does not measure the weight. It only measures the normal reaction or the force applied by the body on the machine. But if the Man is not moving, there is no acceleration, nothing. It will always measure the normal reaction, which will be equal to the weight of the body. So it measures the weight indirectly. Do we understand this? Yes or no? We understand this? Yes or no? Okay. Now comes the case of a spring balance. Have you seen a spring balance? Has anyone seen a spring balance?
Yes.
So spring balance basically consists of a spring and a hook attached to that spring, and then you can do what? Then you can hang a body onto it, and it will tell you, what will it tell you? What does the spring balance tell you? What does the spring balance tell you? This is the diagram of a spring balance. What does a spring balance tell you? If I draw the free body diagram of the weight here, the weight of this body is mg, and this will be the tension in the spring balance, or the force exerted by the weight on this spring balance. This spring balance just consists of a spring. The spring balance just consists of a spring. Now, in normal condition, what will happen? This T, the force in the spring balance, or the force exerted by the block on the spring balance, would be equal to mg. Yes or no? Do we understand this? Do we understand this? Yes or no? So, what does a spring balance measure? It does not measure the weight. It measures the value of this T, which is the force applied by the weight on the spring balance. Are we getting my point? Yes or no? Now, in normal condition, this force exerted by the spring balance, the force exerted by the block on the spring balance will be equal to the weight, and therefore we can say that it measures the weight, but it does not measure the weight. It only measures the force applied by the force applied by the weight on the spring balance. So a weighing machine only measures the normal reaction, and the spring balance only measures the force applied by the block on the spring balance. Do we understand this? Yes or no? So whenever someone asks you what is the reading of the weighing machine, or what is the reading of the spring balance, what do you mean by the reading of the weighing machine or reading of the spring balance? The reading of the spring balance or the reading of the machine simply means the value of this normal reaction or the value of this tension. Do we understand this? Anyone understands this? Yes or no? A spring balance or a weighing machine only measures the force exerted by the block or the body on top of it. Whatever you have kept or whatever you have hung, they just tell you the value of that force and nothing else. Everyone understands this? Yes or no? Yes or no? Okay. Now comes a small question. What will be the reading in the spring balance if I call this as spring balance number 1, and if I call this as the spring balance number 2? Remember, an ideal spring balance is taken as massless, so it does not have any mass. The question is very simple here. What is the reading in the spring balance 1 and spring balance 2? Can I have the answer for this one? I'll give you a minute to think. So, do I have the
200 Newtons, sir.
answers? What will be the reading on the spring balance one? Take G as 10 Newton, 10 meter per second square. What is the reading in the spring balance number one?
100 Newton.
200 Newton. That will be the force exerted by the block on the spring balance. What will be the reading in the spring balance number two? What will be the reading in the spring balance number two? There is no mass of the spring balance one. So reading in the spring balance 2 will also be equal to 200 Newton. Do we understand this? Yes or no? No, yes. So it's a very simple concept. Everyone understands this concept? Yes or no? The reading of the spring balance is nothing but the reading of the force applied by the body on the spring balance. We understand this? Yes or no? Okay, then I move on to the next question, and this is the next question. Question number 2. A man of mass 60 kg is standing on a weighing machine number 2 of mass 5 kg placed on ground. Another same weighing machine. So weighing machine is same. Another same weighing machine is placed over the man's head. A block of 50 kg is put on the weighing machine number 1. Calculate the readings of weighing machine number 1 and weighing machine number 2. I'll give you 2 minutes to do this. So let us now find out the answers of both the cases. What will be the reading in the first weighing machine? The weighing machine which is painted as pink. And the answer is, take G as 10 meter per second square. What is the answer in the first weighing machine? What is the reading of the first weighing machine?
100 Newtons.
The reading of the first weighing machine is the force exerted by the upper block, which will be equal to the weight of the block, and that would be 500 newtons. Well done. What will be the reading in the second weighing machine?
100 Newton.
Green one. Which is the green one? What will be the reading in this one?
600 newtons.
100 Newtons.
It would be equal to 1150 newtons. Because it will be reading the weight of everything on the top of it. There is a man whose mass is 60 kgs. There is a weighing machine whose mass is 5 kg. And there is a block whose mass is 50 kgs. It will be reading everything. If you take all these three as one thing, it will be reading the force exerted by this three on this. And that will be equal to 115 kgs. So the reading in the second weighing machine will be 1150 newtons. Do we understand this, everyone? Anyone having any doubt, please ask. Yes or no? Do we understand this, everyone? Shall we move ahead with the next question? Yes or no?
Yes, sir.
Everyone understood what is the problem? Weighing machine only measures the force applied by whatever is on the top of it. Does not know who is standing on top of it. Man or man ke top pe what is there. He will just measure them as one. Do we understand this? Yes or no? Then let me take you to this question where I have a man of mass 60 kg, but now this man is in a lift, and this lift has an upward. This lift has an acceleration as well as it has a velocity. There are 6 or 7, I think 8 different cases given of different accelerations and different velocities in all these 8 cases. In all these 8 cases, you have to find out what is the reading of the weighing machine. Remember what we have already read about inertial and non-inertial frame. Do we remember this? Yes or no? So I'll give you 2 minutes to think about this and tell me the answers in each and every case. 8 minutes are there, 8 cases are there. I'll give you 3 minutes to solve them. Best of luck. So are we ready with our answers? Yes or no? Okay, tell me the answer in the first case. In the first case, acceleration is 0, velocity is 0. What will be the reading in the weighing machine?
600 newtons.
600 newtons is the first answer. Second case, acceleration is 0, velocity is 2 meters per second. What is the answer in this case?
Newtons.
How much?
300 newtons.
300 newtons. How did I get 300 newtons? No, 600 newtons is the answer. It just reads the normal reaction. It does not change. It is same as 3 and 600 newtons. Number 3. Acceleration is 0. And the velocity is minus 2 meters per second. What is the answer in this case? The answer in this case is 600 newtons. Remember, the block remaining at rest or a system moving with a constant velocity, they are inertial frames. Don't have to do anything in that. So in all the 3 cases, answer is 600 newtons. Do we understand this? Yes or no? Let us come to the 4th case. In 4th case, remember the acceleration is upwards. Acceleration is upwards, 2 meters per second square. What is the answer in this case now? Acceleration is upwards. Yes?
720 newtons.
720 newtons. How did you get? Now I have to apply a pseudo force in the downward direction. M into A. So the effective G becomes G plus A. G is 10. 10 plus 2, 12. Now the answer is 720 newtons. Everyone understands this? Yes or no? 5th one. The acceleration is minus now, negative now. Negative means it is moving down. Negative 2 meters per second square. What is the answer in this case? Case number 5.
480 newtons.
Now the lift is accelerating downwards, so I have to apply pseudo force upwards. So your effective G becomes G minus A, 10 minus 2, 8. And 8 multiplied by 60, 480 would be the answer in this case. Everyone understands this? Yes or no? Pink one is the case when the lift is moving up with an acceleration. Remember, acceleration. Green one is the case when the lift is moving down with an acceleration. Let us move on to the 3rd case. 6th case. Acceleration is 2 meters per second square. Velocity is 2 meters per second. What is the reading in the spring balance now?
720 newtons.
720 newtons. Same case. It only depends on the acceleration because then you have to apply pseudo force. Then we come to the next case. Acceleration is 2 meters per second square. Velocity is minus 2 meters per second. What is the answer in this case?
720 newtons.
The answer in this case is also 720 newtons. Everyone is understanding this? Yes or no? Just have to apply pseudo force, nothing else. The last case acceleration is minus 2. What is the answer in this case?
480 newtons.
The answer in this case would be 480 newtons. Everyone has understood this? The concept of pseudo force?
Sir.
Okay, one more question. To everyone got the answers? Yes or no? Now you have one more chance. One more chance. And the same question is being repeated for your spring balance. I will give you a minute to tell me the answer in all these cases. Instead of a weighing machine, now I have a spring balance. So let us now get back to solving this question. In the first case, what is the answer?
100 newtons.
First case, the answer is 100 newtons. It will rate the tension, and tension is equal to mg. Second case?
100 newtons.
Second case is also 100 newtons. Third case?
Clared.
Everyone understands this? Fourth case?
120.
Fourth case, it is going up. So we have to apply to the downward direction. 10 plus 2, 120. Fifth case?
80.
80. Sixth case?
120.
Seventh case?
120.
And eighth case?
80.
Everyone understand this? Yes or no? Okay, great. This is how we solve questions on pseudo force. Do we get this? Yes or no? Now, up till now, what was happening was the lift was moving up and down. Now, what will happen if instead of up and down, there is no lift, there is something else which is moving, and not up and down, it is moving, let us say, sideways. Remember, the question remains same. So this is the question now. A block of mass 1 kg lies on horizontal surface in the truck. The coefficient of static friction between the truck and the surface is 0.6. What is the force of friction on the block if the acceleration of the truck is 5 meter per second square? I'll give you 2 minutes to think how you need to do it. One way of doing the question is you can find out whether this block will remain stationary or not. This is a very practical problem. Something is on a truck. Sometime when the truck is moving very fast, the block may move. You have to find out whether the block moves or not. That is the hint. I'll give you 2 minutes to solve it. So, how are you supposed to do this? Now, the best way to solve this problem would be where? If you sit on the top of this truck, it becomes easier for us to solve this problem. Yes or no? Now if I draw the free body diagram of this block, this is 10 newtons. This is the normal reaction N. Yes or no? But apart from this normal reaction, this is the real force which is acting on it. Now, since the truck is accelerating in the forward direction, and I want to make the equation from this, I will have to apply a pseudo force. M into A. Yes or no? Now, you have to find out the force of friction. Now, let us find out the value of the normal reaction first. What is the value of the normal reaction? Normal reaction is 10 newtons. Yes or no? So, normal reaction is 10 newton. Let us find out the value of this frictional force which is trying to move it here, according to us. What will be the value of this? Mass is 1 kg and acceleration is 5 meter per second square. So the force which is trying to move it here is 5 newtons. Yes or no, beta? Now, to find out the value of frictional force, I can find out what is the, see, the coefficient of static friction is given. So I can find out Static friction is not constant, it varies. I can only find out from this the maximum value of static friction, that is the limiting friction, yes or no? And the value of limiting friction will be 0.6 multiplied by 10, which will be equal to 6 newtons. That means friction can go up to 6 newtons. Friction can go up to 6 newtons. Here the force which is trying to pull it is 5 newton. The question is, first question that I'm asking, will the block move with respect to the truck? Will it slide? Will it move with respect to the truck? Yes or no? Will it move or will it not move with respect to the truck?
Yes, sir.
Yes or no?
Yes, sir.
No, sir, it will not move because the static friction is much more than the force which is trying to move. So it cannot move with respect to the truck. And the value of static friction here will be 5 newtons in the opposite direction, because static friction can go as high as 6 newtons. If the force on the other side was more than 6 newtons, then only this block can move with respect to the truck. Do we understand this? So in this case, this block cannot move. This block, with respect to the truck, it will just remain there. Now, if I can ask you, how much should be the acceleration of the truck so that the block begins to move? Can anyone tell me? What should be the acceleration of the truck so that the block cannot remain stationary, it has to move? What should be the acceleration at which this block starts to move? Can anyone give me that answer?
Sir, 5 meter per second square.
At 5 meter per second square, it is not moving, bacha. At 5 meter per second square, it is not moving. It will only move when the friction reaches its maximum value. The maximum value of friction is 6 newtons. To produce 6 newtons of force, the mass is constant. The acceleration of the truck must be how much? 6 meter per second square. It must be greater than 6 meter per second square. If it is greater than 6 meter per second square, limiting friction will not be able to stop that truck, stop that block, and the block will start to move. Do we understand what is happening here? Yes or no? Okay, that is good. The only thing is, this question is not, we are not able to do it at present because we have not done static friction. Yes or no? We are still to do friction. So once we do friction, what I will do is I will come back to this question. I thought that I forgot that we have not done friction because normally I do pseudo force after friction. We have not done friction, and that is why you are not able to solve this question. So I will put a mark on this question. I will put a mark on this question, and we will solve this question once again when friction is done. Okay, got it? I thought that I have told you about friction. I just forgot it. So let me now give you a question which does not require friction. So remember, in most of the question of pseudo force, this friction might come. We have not done friction up till now. I had forgotten it. Sorry, my mistake. Let me give you a question where friction is not required. And how can I make that question where friction is not required? This is, let us say a block. This is a block, and this block can move with respect to the ground. Now on this block, I have got 2 blocks with pulley. This is a 2 kg block and this is a 3 kg block. I must remember that friction is absent here. Now, if there is no friction, what is going to happen to the system? What is going to happen to the system? There is no friction anywhere. What is going to happen to the system? As soon as I leave it, what will happen? What will happen?
Will move, sir.
Yes, beta? The 2 kg block will come down and the 3 kg block will move forward. Yes or no? Yes
Sir.
or no?
No.
Now, we understand this? The 2 kg block will move downward and the 3 kg block will move forward. We understand this? Yes or no? Yes or no? We understand this? Yes or no?
No, sir.
We understand this? This is assist. 2 blocks are attached to each other. They are kept on a surface. There is no friction. If I leave the system, what will happen? There is no friction. Friction has not come. What will happen to these blocks? This block will go down and this block will go here. Yes or no? We understand this? Yes? We can find out the acceleration of this block. Yes or no? Total pulling force, this, that, we can do it. Yes or no? Now, the question is, can I do something without touching the block so that these 2 blocks do not move? Can something be done such that these 2 blocks do not move and I can't touch them? I can't touch these 2 blocks. So what I am going to do, I am going to move this bigger block with an acceleration A. I'm going to move this bigger block with an acceleration A. And that is your question. With how much acceleration I should move this block so that the green block and the blue block remain at rest with respect to the bigger block. Everyone understands the question? There is a green block, there is a blue block. If I do nothing, green block, blue block moves down and green block moves forward. With how much acceleration I must move the lower block so that the 2 blocks remain at rest with respect to the bigger bada block. I'll give you 2 minutes to solve this. So how are we supposed to do this? What is the best place to solve this? The best place to solve this is by sitting on this bigger block and then making the equation. Now, how do I make the equation? This is 30 newtons. This is normal reaction, N1, let us call it. This is T, tension in the string. We all understand this free body diagram? Okay, let us draw the free body diagram of this block. This is 20, this is T, and this block is in contact with this one. So I apply a normal reaction N2. Do we understand this? Yes or no? These are the free body diagrams. But now I'm making the equation of this block from the top of this bigger block which is accelerating. So what I must do, I must now apply pseudo force. So this block is accelerating towards right, so I have to apply pseudo force towards left. Yes or no? Do we understand this? So this will be 3 multiplied by A. Yes or no? 3 times 3 is mass, A is acceleration. On this block, it will be applied like this, 3A. Yes or no? Yes or no? Now remember, this block has to remain stationary, so forces must balance out. And that is your answer, my dear friend. Forces must balance out. So your normal reaction N1 will be equal to 30. Yes or no? Then your pink equation, your T must be equal to 3A. Do we understand this? I will write this equation here. T will be equal to 3 times A. Then we look at this blue equation. Normal reaction N2 will be equal to 3A. Yes or no? So let me write it here. Normal reaction N2 will be equal to 3A. Then I can write this equation. T will be equal to 20. Yes or no? This T will be equal to 20. From here, you can find out the value of acceleration. Your acceleration will be 20 by 3. In fact, if I write it in terms of G, it is 2G by 3. So if I move this block with an acceleration of 2G by 3, what will happen? These two blocks will not move. They will remain at rest with respect to the bigger block. Do we understand this? Yes or no? Everyone understands this? Now I can ask you a question. If this acceleration is less than 2G by 3, then what will happen? Well, then the bigger block, then the hanging block will go down and this block will move here. But if the acceleration is greater than 2G by 3, then what will happen? With respect to the bigger block, the 3 kg block will move here and the 2 kg block will start to move upwards. Do we understand what is going to happen? Interesting. At 2G by 3, the blocks will remain stationary, less than 2G by 3 here, more than 2G by 3 here. Do we understand this? Yes or no? Everyone understands this? Can I have raised hands from everyone? Okay, now I'm going to give you 2 cases which you are going to remember and keep them as note in your copies. We can solve them, but there is no need of solving them. This is case number 1. Case number 1, same case as what we had done there. This is just in case of an inclined plane. So what is there? Case number 1. Small block M remains at rest. With respect to capital block M. So if you have an inclined wedge and you have kept a block on the top of this inclined wedge, how much acceleration should that wedge have so that the block remains at rest? This is the same question as what we have done in this case. The only difference is there were 2 blocks attached by a string. Here there are 2 blocks kept on top of each other. So the concept remains same. Do we understand this? The concept remains same. You have to remember that the acceleration for which the upper block remains at rest, this acceleration will be given by G times tan theta. This question has come many times in IIT. You just have to write this. The acceleration of the lower block has to be G tan theta, and the value of this force F with which you must move this both blocks will be equal to capital M plus small m. G tan theta. Can you remember this diagram and this concept? Yes or no? No, yes. I'll give you a, have you noted it down, bacha? Yes or no? No, yes. So then you can see a question here, a very simple question based on the concept. You don't have to calculate anything. You just have to tell me the answer for this one. A triangular block of mass capital M rests on a smooth surface. In the figure, a cubical blocks of M is kept on the inclined surface. All the surfaces are frictionless. What force must be applied to capital M so that small m remains stationary with relative to the bigger block? And don't have to write the entire question, just draw the diagram and tell me the answer. What is the answer for this one? What is the answer for this one?
M plus MJ tan 30 degrees, sir.
M plus mg tan 30 degrees. Remember this concept. Remember this question. Remember this. One wedge, one block, acceleration this side. How much should be the acceleration so that the block remains at rest? The answer is g tan theta. Do we understand this? Then there is a cousin brother of this question. There is a cousin brother of this question. In that cousin brother of this question, I move the block in the other direction. 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 I have not said anything. I move the block in the other direction. In this case, what will happen? There is a special case where case number 2, block M falls freely under gravity. Block small m falls freely under gravity. How fast should I move the lower block? Remember, the direction of acceleration has reversed here. The direction of acceleration has reversed here. The direction of acceleration has reversed here. How much should be the acceleration of the lower block so that the upper block falls freely? In one case, it is falling freely under gravity. In second case, it is remaining at rest. Do we understand this? That is why I have repeated the same thing 15 times. The answer in this case for this acceleration, remember, don't get confused, is g cot theta. So for block to fall freely under gravity, the answer is g cot theta. For block to remain stationary, the direction of acceleration are reversed. The direction of acceleration are reversed. For block to remain stationary, it is g tan theta. For block to fall freely, it is g cot theta. Do not forget it, whatever happens. And this is the question on this. And the answer for this question is simply g cot theta. Do we understand this? Do not forget this, because one of the most difficult question in JEE came from this concept. What they had done in the previous question, they had just attached this wedge to another block. So there was string attached, and they had asked what is the mass of the other block. So what they had done in that JEE wala question, they had connected a string and then they had hang a block here M1, and they had asked what should be the value of M1 so that this system small block M remains stationary. You already know the acceleration. You can simply make the equation of this block and you are done, because the force here is will be equal to the tension T. You just put tension T here in this. You know the value of acceleration. Once you know the value of tension, you can write the equation of this block and you can find the mass of this block. Do we understand this? Yes or no? So they can again frame a question based on this concept. Remember this, keep it in a safe deposit. I'll see you in the next class. We are done with pseudo force once and forever. Next class, we'll be starting with friction. And again, we'll come back to that question and see how that question is done. Take care. God bless all of you. Bye-bye.
Thank you, sir.